Something really crazy is happening in the early universe in terms of early star formation and early galaxy formation. If that's the case, is that a major rewrite? Yes, you think so? Yes, but we'll say I could probably be wrong. This kind of data in a fraction of the time that we were before is astonishing. I think a lot of the records that we have in the current day universe are going to be broken really soon. Look at this image. This is a newly discovered early galaxy that existed about 13 billion years ago, but researchers found that this galaxy is far more massive and mature than expected for a galaxy in the infant universe. This is not the first time that Webb has found such galaxies in the early universe. Ever since the Webb telescope began its journey, it has been challenging our standard cosmological theories. The amazing telescope did not stop here. This time, the telescope has revealed a worrying thing about the universe. Recently, Nobel Prize-winning science revealed that the James Webb telescope has finally confirmed that our understanding of the universe was completely wrong. Well, it is not about big and bright galaxies, but this time some more important and new observations from the James Webb telescope have shattered the age-old cosmological theories. Let's consider this. One of the pillars of cosmology is that the spatial distribution of matter in the universe is uniformly isotropic. This means that everything looks the same in all directions if you look over large enough distances. This is obvious since the forces are expected to act equally throughout the universe on a large scale and should therefore produce no observable inequalities in the large-scale structuring over the course of evolution of the matter field that was initially laid down by the Big Bang. Wherever you look, you will find the same density of matter, the same temperature, and the universe is expanding equally everywhere. For more than a century, scientists have been developing various cosmological models with the assumption that our universe is uniform in all directions. The Big Bang model, which is the best theory to understand the universe, is also based on this assumption. The cosmic microwave background radiation also shows that the universe is the same everywhere. However, a recent study published on February 6 in the astrophysical journal Letters suggests that there may be something seriously wrong with this assumption. Recently, astronomers have confirmed that the expansion rate of our universe is not the same everywhere. In this paper, they reveal that depending on where we look, the universe is expanding at different rates. This is a big problem now because if the universe is expanding at different rates in different places, it will create a major problem for astronomers. This new study also suggests that we may be completely wrong about the current estimated age and nature of our universe. David Gross, a Nobel Prize-winning astronomer, said, "We wouldn't call it a tension or problem, but rather a crisis." Let's delve deeper into this discovery and learn how the new Webb telescope discovery confirms a crisis in cosmology. Isotropic, then it would mean that the physical laws as we understand them are impossible to comprehend. Just over the cosmological horizon, the force of gravity might act in reverse, the speed of light might be slower than walking speed, and unicorns could be real. Well, this new discovery of the Webb telescope has caused a great debate among astronomers. This is because the non-uniform expansion of the universe challenges the cosmological principle, and it is one of the foundations of astronomy. We're living in a very interesting era of astronomy at the moment. Over the past few months, our 100-year-old astronomy has been going through many challenges, but what the James Webb telescope has recently found in the early universe has stunned astronomers around the world. Scientists are saying that this discovery can bring a huge change in our basic understanding of the universe. But why are scientists suddenly worried about our century-old theory? What has the Webb telescope discovered that could change everything we know? Well, this week some of the world's leading cosmologists will meet at the Royal Society in London to ask the question, what if our fundamental assumption about the universe is wrong? The meeting comes after a number of high-profile astronomical observations have challenged the conventional view. According to Professor Subersaka, a cosmologist at the University of Oxford and co-organizer of the meeting, we are in cosmology using a model that was first formulated in 1922. We have great data, but the theoretical basis is past its sell-by date. More and more people are saying the same thing, and these are respected astronomers. What he really wants to say is that if you zoomed out on the universe well beyond the level of planets, stars, or galaxies, you will eventually see a vast uniformly patchy expanse with no notable features. The universe will appear uniform wherever you look, and the distribution of matter will be the same everywhere. At least, that has been the conventional view. The principle that everything looks the same everywhere is a fundamental pillar of the standard model of cosmology. All the cosmological models we have right now are based entirely on the premise that the universe is the same everywhere. For example, the standard cosmological model states that dark matter played a key role in the formation of the first stars and galaxies right after the Big Bang. The distribution of dark matter in the universe after the Big Bang is homogeneous, which means that the density of dark matter was the same everywhere. This is one of the basic assumptions about the universe. This idea successfully explains why the distribution of matter in the cosmic microwave background radiation is uniform. But in recent months, scientists have discovered several unexpected things that prove the universe may not be the same in all directions. Here is the first observation that raises the possibility that the universe is slightly imbalanced. Recently, the Webb telescope made some surprising discoveries. All these little dots are stars, all these little dots are galaxies, some of which are bigger than our own. Scientists found that the universe might not be as symmetrical as we once thought. When scientists studied a massive list of more than 1 million super-bright galactic cores called quasars, they noticed something strange. One side of the sky seemed to have about 0.5% more quasars than the other side. It's like noticing that one side of a cake has more frosting than the other. On the other hand, Alexia Lopez, a PhD student at the University of Central Lancashire, has discovered what appeared to be cosmic megastructures named Big Ring and Giant Arc. These shapes, traced out by galaxies and galaxy clusters, occur on a scale beyond which the universe should be smooth and effectively featureless. Alexia Lopez said, "When we're finding a list of structures that are exceeding this scale, are they challenging this assumption that is so fundamental in cosmology? Maybe there needs to be more of a critical analysis of our standard model." The discovery of such large and massive structures shows that the universe is not the same everywhere. The distribution of matter in the universe is not uniform. Some parts of the universe are way more dense than other parts. Now let's look at another unexpected finding in physical cosmology and astronomy. Dark energy is an unknown form of energy that affects the universe on the largest scales. Its primary effect is to drive the accelerating expansion of the universe. Assuming that the standard model of cosmology is correct, dark energy is the dominant component of the universe, contributing 68% of the total energy in the present-day observable universe. However, it dominates the universe's mass energy content because it is uniform across space. If dark energy is responsible for the expansion of the universe, and dark energy is the same everywhere in space, then according to our physics, the expansion of our universe should be the same everywhere in the universe. Over the centuries, astronomers have adopted many methods to measure the exact value of the expansion rate, but surprisingly, each method has produced different values. It's as if the universe is expanding differently for different observations. Initially, some scientists thought that the disparity could be a result of a measurement error. But recently, Adam Rees, professor of physics and astronomy at Johns Hopkins University, said, "We've now spanned the whole range of what Hubble observed, and we can rule out a measurement error as the cause of the Hubble tension with very high confidence." Also, the new images of the James Webb telescope confirm that the previous measurements are correct and the universe is expanding differently in different places. This discrepancy in the value of the expansion rate of the universe suggests that perhaps the universe is not the same everywhere. Well, all these discoveries are now suggesting that the distribution of dark matter and dark energy is not uniform in the universe. This new thinking just shattered the century-old belief that the universe was homogeneous and uniform. Understanding the true nature of dark matter and the cosmological constant is one of the biggest challenges in modern cosmology. All these discoveries have posed a serious threat to our basic understanding of the universe. We still don't know what exactly is going wrong with our theories. Scientists are working tirelessly to gather more evidence and refine our understanding of these fundamental aspects of the universe. Amid all these dilemmas, recently, a group of astronomers has revealed a shocking discovery about the nature of dark energy, and they are claiming that this discovery can solve the crisis in cosmology. Recently, the Dark Energy Spectroscopic Instrument Collaboration just released a slice of the largest 3D map of the universe ever made, in which they analyze their data on a large-scale clustering of 6.4 million galaxies and quasars across a third of the sky, all the way back to 1.5 billion years after the Big Bang. This new map of the universe hints at the shocking possibility that dark energy is evolving, and if this is true, it just turns cosmology upside down. Einstein believed that the cosmological constant, or dark energy, is a constant parameter. But new discoveries have seriously challenged this century-old idea and revealed that dark energy has evolved over time in the universe. This is probably the reason why we get different values for the expansion rate of the universe. These are major discoveries in cosmology that could lead to major changes, and scientists from around the world have now gathered to rewrite our basic understanding of the universe. At this point, our century-old cosmology needs major revision. All these new discoveries demonstrate that while nature can be more imaginative than we are, once we know what nature is, theorists would find a natural way to explain it and claim that they knew it all along.